Well, to finish up chapter 2, in section 2.4, we're going to talk about the limits of a special kind of sequence, a monotone sequence. And first, let's define what that is, and the definition will look quite a bit like this definition of a monotone sequence. The function f with domain capital D going into the reals is increasing, or decreasing in red there, if for every x and y in the domain where x is less than or equal to y, the height of the function, or the value of the function f of x, is less than or equal to f of y. And if it's decreasing, f of x would be greater than or equal to f of y. And if it's either one of those, if it's either increasing or decreasing, then it's monotone. And that's the way the book defines it. I like to call these, I like to call it non-decreasing instead of increasing, because you could have flat spots on the graph and it's still, by this definition, the constant function is both increasing and decreasing, and therefore monotone. And recall 3 reasons that a function may not have a limit at a particular point R. You could have a jump, which means you've got something like this. Maybe it's not defined there, and then it jumps up. This would be x0. It could be oscillating near x0. And what example did we use for that? Sine of 1 over x. It was oscillating something like this. Never touching it, but oscillating back and forth as x naught goes to x0. And the last one is the function is unbounded. So at x0, you could have something like this. Not defined, and it's unbounded as x gets near x0.